Hi Year 10s. So this is our last chapter for statistics that we need to go through. It's 5I called Line of Best Fit. Now I'm not going to go into a huge slideshow, so I'm sorry if it's a bit hard to see, but I need to use this because we're going to need to use a ruler. Okay, so 5I, Line of Best Fit. We're looking at bivariate data, okay, so remember that bi meaning two and variate is variables. So we've got two variables and they're showing a clearly defined positive or negative correlation. Correlation just means like a relationship. They're showing something, combined, it's showing either positive or negative values. So a straight line can be fitted by eye. Okay, so we can fit a straight line onto a graph to show whether your data is positive or negative. So a line of best fit is positioned by eye. By eye, that's meaning it's literally just yourself putting your line on there. It's not a super accurate thing to do, but it can help predict points. And to do that, what you do is you balance the number of points above the line with the number of points below the line. So looking over here at this graph, okay, you've got your bivariate data because one variable is x and one variable is y, and you've got all your points, so these x's are all points. So what we're doing is fitting a straight line onto our graph, and we need to make sure that the number of points, there's the same on the top and same on the bottom. So for this one, we can see that there's 1, 2, 3, 4 on this side, and on the other side, there's 1, 2, 3, 4, 5. So obviously there's an uneven thing, so that's okay, but it's pretty much even, so points on the top and points below the line. Okay, so it's pretty even. And from this one, we can see that our points are getting negative. Okay, there's a negative correlation because the line's going down. Okay, so that's how we fit the line of best fit. The distance also, just looking at this point here, the distance of each point from the trend line also needs to be taken into account. So that means all of your points here, okay, the distance going up the line have to be taken into account, just making sure that there's none that are too far away. And the other point is saying that outliers, they should be ignored. So if we have a point like over here, that's an outlier. See how it's going to be really hard to put your line, because how are we going to get, you'd have to start drawing a line kind of like that to include it, but you don't need to, so don't worry about that. So the line of best fit here can be used for, there are two big words, but don't get worried about those. So we've got interpolation, yeah. So it's finding unknown points within the given data range, okay? So what that means is that inter meaning inside, so in the data we already have, that we might need to find an unknown point, okay? So we might want to know, well, what about when x equals whatever number this is, what does y equal? So what we can do is go up to our line of best fit. Well, it's probably there. This is all approximate, which means that can tell us what our y value is. Okay. Extrapolation, so this big word here, is finding unknown points outside the given data range. So because we've got our line of best fit, if we had a bigger one, we can tell that, or we can predict that there's another value outside of the range, because let's say this was a bigger graph and our line just keeps going, okay? We could predict what point is here, because we know that our line's going to keep going straight like that. So it gives us an approximate value. So let's do an example to get this all to make sense. So here we've got, consider the variables x and y. So I might, so they're here in the table. Why is that? Yeah, x and y. So A says draw a scatter plot for the data. So I've already got my graph here, which is handy. So when x is 1, y equals 1. So we're going to go, there's a point here. Next one at 2, 2. When x is 2, y is 2. When x is 3, so here x is 3, y is 2. Okay, so 3, y is 2. Actually, let's put an x, label our axes, so that's x and this is y. Next point, when x is 4, y is 3. So the point will go here. When x is 5, y is 4. When x is 6, y is 4. And when x is 7, y is 5. So here. All right, so that's our scatter plot. We've put our points on the graph. Now, B says, is there a positive, negative, or no correlation between x and y? So we can kind of see as x gets bigger, okay, going like this, as x gets bigger, our points get higher, don't they? Okay, which means there's a positive correlation. Okay, so our points are positive. Okay, for C, fit a line of best fit by eye to the data on the scatter plot. This is when it's probably good to get a ruler. So I've got one here and I might use red or green. Yep. Okay, so moving it around a little bit. How many points do I have? 1, 2, 3, 4, 5, 6, 7 points. Okay, so I'm going to try to get 3 on each side and probably 1 going through my line. So let's see, if I drew a line, I'm trying to get it as even as possible. Maybe a bit more like this. Because that's going to get 3. Yeah, let's do this. So I'm going to draw my line going like this. Okay. Actually, that's not very good because it's only got like 1 and 2 points on that side, whereas the other side has too many. So I'm going to do that again. Oops. Okay, let's try again. Oh, I guess what we could do is see we've got these 2 on one side. We could have these 2 on the other side and our line could go through the middle there. So that'll keep it really even. So let's do that. And put our line of best fit by eye, just meaning I'm just doing this by myself. And we'll take it off. So that's a pretty good line of best fit because I've got 2 points on this side of the line and I've got 2 points on the other side and my line's going through the other 3. So it's really even. Okay, so that's my line of best fit, so that's C. Get my rainbow back. And D says use your line of best fit to estimate. Okay, so I is, so this one, we're looking at y, so we're trying to find y when x equals 3.5. So x equals 3 is down here, which means 3.5 is here. Okay, so we're going to go up to my line of best fit, bang, 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 up to here. And well, what does y equal here? So we need to go over to our y line to there. Okay, what does it equal? Well, y equals, what's the number here? That's 3. So it's between 2 and 3, so it's going to be 2.5. So y equals 2.5. That's actually hard to see, isn't it? Y equals 2.5 when x equals 3.5. Okay, let's do another one. So what is y when x equals 0? So x equals 0 is here. What does y equal? Where does this line cross? So we haven't quite gone as far enough, have we? There we go. What's the value there when our line hits when x equals 0? What's the point here? It looks like it's halfway. So if this is 1, that's 0.5, that's half. It looks like it's between 0 and 0.5, doesn't it? So it looks like it's about 0.25 because it's halfway between 0 and a half, which is that. Okay, now these could be slightly off. Again, it's all approximation, so you might get a couple of different answers to others. It depends on your line of best fit. Okay, a couple more. What is x when y equals 1.5? Let's use a different colour for these ones, purple. So when y equals 1.5, so 1.5 is here. Okay, we're going to go over to my line of best fit and stop there. Okay, and go down. So what is x? What value is x? If we go down here like this, what is that value? Okay, so again, that's 1. This point is 1.5, so it's between 1.5 and 2. So that's actually going to be 1.75. That's the number between those two. So see, this is what we call interpolation, because we're looking at other values that we don't know, but it's within our data. Yeah, okay. And last one, x. What is x when y equals 5.5? So 5.5, that's 5, so 5.5 is here. So we're going to go all the way along until we hit our line of best fit, which is here. Okay, so what is x? Let's go down. X is 8, see? X is 8 at this point when y is 5.5. Okay, so that's why we use line of best fit to predict points on our graph. So I hope that makes sense. Obviously let myself or Miss Bristow know if you have any trouble.